Alright, today we're going to look at Introduction to Proofs and Patterns. This is the start of our next chapter here. And so one of the things we're going to look at is finding a pattern in a sequence. So the first three questions here say, determine the next three terms in each given sequence. So the first one says 3, 9, 15, 21, and we need to figure out what the next three are. So you know what I would prefer you to do is pause the video, write these down, and then see if you can fill in the blanks. See if you can figure out what pattern is going on here. And then once you're done, start the video and we'll talk about it. Okay, so what I'm going to do is I'm going to look at how far these are going up or down each time. So one way to do that, I really like to make a little V here to say from 3 to 9 it goes up by 6. So I'll put a little plus 6 here. And then from 9 to 16 it goes up by 6 again. And then from 15 to 21, it goes up by 6 again. So obviously the pattern is you just add 6. So from 21 to the next number, we're going to add 6. So 21 plus 6 is 27. Great. All right, so then 27, the next number, we're going to add 6. 27 plus 6 is 33. And then lastly, we add 6 to get to the last number. 33 plus 6 is 39. So we got the first one down. Fantastic. All right. The next one, we go from -9 to -4. That we add 5. Okay, and then from -4 to 1, we also add 5. So I think I see a pattern developing here. From 1 to 6, another plus 5. So the pattern is we just add 5. So let's add 5 to 6. 6 plus 5 is 11. 11 plus 5 is 16. And 16 plus 5 is 21. So first two, pretty straightforward, just add the same number. All right, let's look at the next one here. This one, from -6 to 4, that's a difference of plus 10. From 4 to 17, that would be a plus 13. Uh-oh, this isn't looking good. These were all the same numbers. Now we got some different numbers here. From 17 to 33, that's a plus 16. And from 33 to 52, that's a plus 19. I think I see the pattern here. So we're adding 10, adding 13, adding 16, adding 19. What we're doing is each number we're adding, it keeps going up by 3. So this is called the second differences. The second difference is 3. On here, these were the first differences. Let's write that down here. This is the first differences. First differences. Okay. On here, this was the second differences, the 3. So the plus 10, plus 13, plus 16, plus 19, those were the first differences. The 3s are the second differences. So what we're looking for is if the first differences are constant, maybe let's write that down here. If the first differences are constant, then what that means is it's linear. What I mean by linear is it's going to be in the form, it's going to be like a y equals mx plus b form. It's just going to be a line. If the second differences are constant, then it's going to be a quadratic. Oops, quadratic. And this means you're going to have y equals, and then something x squared plus something x plus some number. So it's going to end up being an x squared equation. And then if you keep going out, if you have some patterns where like the fourth differences are constant, then that's going to be a fourth degree polynomial where it's an x to the fourth, x to the third, x to the second, x to the first, and then a constant number. So whichever difference is constant, that's what type of equation it is. And that's not totally our focus today. What we're trying to figure out is just what's the next three terms. So if we went up by 10, up by 13, up by 16, up by 19, the next one we're going to go up by 22 because that's going to be the next number of 3. So 52 plus 22 is going to give us 74. 74 plus, let's see, we go up by 3, go up by 3 again, is 25. So 74 plus 25 is 99. And then next we go up by 28. 99 plus 28 is 127. So that would be our next three terms. Okay, so this is the first part of today's activity. The next one is we're just going to look at another example. And here we're looking at the first n odd numbers. So if n is 1, that means we're just looking at the first odd number, and that number is 1. And so if we add that up, we get 1. Okay, kind of confusing so far. First two odd numbers, so if n is 2, the first two odd numbers are 1 and 3. So we add 1 and 3 up, we get 4. Okay, so keep doing this pattern. See if you can figure out if there are n odd numbers. So n can be any number. Like if I said there's 100 odd numbers, what would that add up to? So pause the video, see if you can figure that out. This might take you 5 minutes or so, but pause it and see what you can come up with on your own. Okay, so if n is 3, that means we got the first three odd numbers, 1, 3, and 5. Well, 1 plus 3 is 4, plus 5 is 9. And then we got 1, 3, 5, and 7. Those are the first four odd numbers. That adds up to 16. 1, 3, 5, 7, and 9. That adds up to 25. And then 1, 3, 5, 7, 9, 11. That adds up to 36. So the next one, we're not going to put a 49 in here. That's not what I'm looking for. I'm not looking for the pattern. And I got 49 because I know this goes up by 3. I know this goes up by 5. I know this goes up by 7. This goes up by 9. This goes up by 11. So it just keeps going up by the next odd number. But now we're trying to generalize it. So what would there would be some sort of equation or some expression that we could put in this box where we could figure out how many or what the first n odd numbers would add up to. So there's a couple ways to look at this. One way is using this pattern, and then you could develop an equation from that. Another way, if you notice, 1 is 1 squared. 4 is 2 squared. 9 is 3 squared. 16 is 4 squared. 25 is 5 squared. 36 is 6 squared. And so each of these numbers over here, the n, however many terms there are, if we square that, that'll give us the sum of those numbers. So if it's n numbers, we square that. So what goes in this box? It's n squared. So what I mean by that is, like I said earlier, if n were 100, let's say we take the first 100 odd numbers. So 1, 3, 5, 7, 9, 11, 13, all the way up to the 100th odd number, and we add all of those up. When we add that up, we're going to get 100 squared, which is 10,000. And that's a really quick way to figure out the sum of the first n odd numbers. Cool. And so so if somebody comes up to you on the street and says, hey, do you know the sum of the first 83 odd numbers? You're like, yeah, that's super easy. You just do 83 squared. And they'll be so impressed. Okay, last problem for the day. We've got 3 figures here, and I want to know how many tiles are there going to be in the next figure, and the next figure after that, and then in the 10th and the nth shape. So on this one, there are 1, 2, 3, 4, 5 tiles. So we're going to do it just like the first problem. This one, there are 5 tiles. We're going to write a 5 there. Okay, on this one, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 tiles. Alright, so let's look at the next one. Here there are 1, 2, and then in here it's 3 by 4. So this would be 12 in the middle, plus 2 more is 14. Okay, so, one of my inklings is to say, well, it goes up by 5, and then it goes up by 4, and then it goes up by 3, maybe? But I don't know if that's true. I don't know. So let's look at the shapes and see if we can figure out a pattern from there. So what it looks like is there's a rectangle in the middle with 2 little feet sticking out. And then over here, there's a rectangle in the middle with a foot sticking out here and a foot sticking out here. And then there's a rectangle in the middle with 2 feet sticking out. So let's look at this rectangle for a minute. Let's switch over to blue. This rectangle here is 1 wide and 3 tall. So I'm just going to ignore these little feet sticking out. We'll add those in at the end. But this is 1 by 3. And this is our first shape. Okay, let's look at our second shape. This one, if we ignore these feet, because those feet kind of get tacked onto all of these shapes. This one is 2 across and 4 tall. And so then on our third shape, it's 3 across and 5 tall. Okay. Very cool. So I'm guessing on my fourth shape, well, on the first one it was 1 across, on the second one it was 2 across, on the third one it's 3 across, so it's probably going to be 4 across. 4 tiles across, and then the height here, if it's the first one, it's 3. Second one is 4. Third one is 5, so it's always 2 more, it looks like. So if this is the fourth, it's going to be 2 bigger. That's going to be 6. And then that's going to be our middle rectangle, and then there's going to be 1 sticking out here and 1 sticking out there. So this would be 24, because 4 times 6 is 24. Plus 2 would be 26. Okay, so what about the 10th shape? Let's just skip right to the 10th. How far across would it be, and how far down would it be? Well, the fourth shape is 4 across, so I'm guessing the 10th shape is 10 across. And if the fourth shape is 6 tall, the 10th shape would be, well, let's see, that's a difference of 2. So this would be 12 tall. And then we've got this guy sticking out here, and that one's sticking out there. So this rectangle is going to be 120 tiles. Then we got 1, 2 sticking out. So the 10 shape is going to be 122 tiles. Very cool. So what about the nth shape? This is where it gets kind of tricky. So on the nth shape, how far across is it going to be? So remember, n just stands for any number. So if n were 75, what would this be? If n were 160, what would that be? So if this is the 10th shape and it's 10 across, if it's the nth shape, it's going to be n across. And on the 10th shape, it was 12 tall, that's 2 bigger. On the nth shape, it's going to be 2 bigger, so n plus 2. And that's going to be our rectangle. And then we'll have 1 little guy sticking out there, and 1 little guy sticking out there. So the area of this, we go n times n plus 2. Well, n times n plus 2. We would distribute the n, and we get n squared plus 2n. That's going to be the inside stuff. Okay, but then don't forget we got 2 little things sticking out here. So how many tiles will there be in the nth shape? Well, there's going to be n squared plus 2n. That's going to be the rectangle, plus 2 more. So n squared plus 2n plus 2. And you know what? Let's see if this equation works. Let's just plug it in for the 10th. So we'll go 10 squared plus 2 times 10 plus 2, and we should get 122. 10 squared is 100. 2 times 10 is 20. 100 plus 20 plus 2 is 122. And that is fantastic. So, if I asked you, how many tiles would there be in this pattern, how many tiles would there be in like the 1,000th shape? You just put 1,000 in down here for n. So it'd be 1,000 squared plus 2 times 1,000 plus 2, and that would give you how many tiles there would be in the 1,000th shape in this pattern. All right, so that's it. There is another video. Watch the next video, and that will help you with more problems like this if you're still struggling coming up with this equation.